All right. I should be recording and I should be unmuted right now. Welcome to workshop 2, technically workshop 3 if you want to get technical, but since I like, the numbering in computer science, I named workshop 1 workshop 0. So we're on the third workshop, but I call it workshop 2, but you know, just for official purposes. Anyway, uh, last week I discussed some introductory basics to the Java programming language. Uh, Now we're going to be building upon that with a bunch of other things, but I also want to discuss other aspects of computer science that we're probably not aware of and some people take for granted as well. So, with that being said, I'm going to pull up a PowerPoint that I made a couple months ago, but it's pretty applicable for now. Um, all my workshops are recorded, and I have it on my YouTube channel. It's a playlist on my YouTube channel, or it's on the link to the documents on the Discord, Rutgers IEEE Discord. So that should have every single video that I have, or every single workshop recording that I have. Okay. I should have discussed this actually in workshop 0, but it's better if I do it now rather than later. Okay, let's share my screen. Desktop 1. Okay, we should be able to see my screen. Let me present. Okay, so I want to discuss computers real quick because, well, after all, we program on computers and we spend a lot of time with computers, assuming that you're a computer science major. If not, if you're programming, well, you need to understand like just how computers actually process information. And as I said in workshop 0, really the only thing the computers can understand is binary code, as in the zeros and ones that you generally see with pictures that you generally see. But each of that represents something different depending on the context that is used in, right? So a 96 on the keyboard can be different than a 96 that is represented in colors, right? Both have the same numeric code in binary code, but the context is very different. But that's besides the point. Let's just do a quick introduction to computers, and then I'll move on to more Java stuff towards, maybe a couple minutes in. Anyway, introduction to computers. What is a computer? A computer is an electronic machine or device that processes and calculates data faster than humans. And these can come in various shapes and sizes, right? Computers don't have to be that standard laptop, right? So a calculator such as this can technically be considered a computer because it can perform operations, numerical operations that might take some time for us to mathematically or conceptually do, right? We might need a piece of paper to do it, or we could do it in our head, but it will take a lot of time. But this can do it immediately. You also have very big supercomputers like the IBM Watson, right? And I'm pretty sure there are better ones than the IBM Watson. The IBM Watson is like my personal favorite one because I saw it on like Jeopardy one time, and back in like it was many years ago, and I saw it like compete against like my two favorite Jeopardy contestants, right? At the time they were like the top contestants ever to be on Jeopardy, and the IBM Watson pretty much just destroyed them, right? So they can come in various shapes and sizes. They can come in like, the basic ones that fit in your pocket, or they could be the ones where they can be crushing Jeopardy champions, right? So a computer is a very broad term that encompasses a lot of devices. Now, computers, they use programs, right? Which is a set of instructions given to the device that performs a task upon execution, right? So this brings up a very important point about computers that um, although it could have hardware, right? We think of computers as hardware. Important aspect of computers is also the software because the software is what makes the hardware actually work, right? The hardware is almost nothing without the software, right? Something that gives the hardware some type of function. So let's talk about hardware real quick. Hardware is the actual physical machinery that builds up a computer. But again, it's practically useless without programs, as I said, right? So we need to program things, and people that use hardware to program things like this, right? And they can go and use the variety of different languages to program that hardware. And those hardwares have very specific components or very specific functions. So there are five key components that we're going to be talking about: CPU, ALU, input units, output units, and memory. So CPU, this is also known as the central processing unit, but generally you're going to hear it as CPU. And if you're building a PC, then you probably have heard CPU such as like an i5, i7, even i9 at this point. And you can consider it the brain of the computer because it's responsible for executing the jobs instructed through programs. And really the main purpose of the central processing unit, otherwise the CPU, is that it makes sure that the functions are done accurately. So again, a good representation of that would be the brain, right? The brain, or maybe even like the nucleus of a cell, right? So those are good analogies to compare the CPU to. The ALU, it might sound like the CPU, but it has a slightly different function. ALU it stands for arithmetic logic unit, and it performs the computer's calculations and decisions. And this could be a variety of arithmetic operations such as addition, subtraction, multiplication, even division, even modulus, as we said in the workshop one. And basically, this performs all the operations founded upon human logic. Now, input units sound exactly like, it sounds like, right? Input, right? That's hardware that sends out signals to the computers to provide direct data. So your uh, computer's getting something from an outside source, right? And then it's interpreting that data to be used. An example of this is a keyboard, right? So it's getting information from an outside source. So let's say me, right? I'm putting information via the keyboard and it's taking that as input, right? And it's going to display it on the screen. Now, speaking of screens, there's also output units, and this sends information to another device. An example of that is audio speakers. So if you're playing music, there is a code for music within a computer, and then the computer sends that code to audio speakers, and then the audio speakers interpret that code, right? So you could technically say that, like, if you have a computer connected to an audio speaker, the audio speaker's input device would be the computer, but the audio speaker would be the output device or output unit to the computer, right? So they have that type of relationship. And another easy example is video monitors. And there's a variety of other examples, right? So I'm not just saying it's confined to these things. There's a variety of other parts to computers or output units to computers that allow us to have more practical functionalities, right? And really, when you think about it, when you're developing software, it's all about input and output, right? When you're giving if you're making programs for users or usability or functionality, right? You want the computer to get some type of input, and then you want it to spit out something, right? And this can be very applicable to different industries, right? So in like Facebook, for example, right? You want the computer to you want the user to input, let's say, their photo, right? And then you would want the computer to output your friend's photos. That's just an example of how input and output really guide computer science. Memory is very important because, well, we need a place to store all our data. So the computer's memory is capable of storing data, and there's generally two types of data: volatile and persistent. Volatile memory is memory that isn't really kept. And an example of this is the RAM, otherwise the random access memory. And basically, like when you shut down your computer, the RAM is, a clean slate because, well, it's the RAM, right? And there's a lot of jokes saying that, like, Chrome uses too much RAM because, well, it's using a lot of data at the same time. So that's why there's different memories for data, right? So if you have more, let's say 16 gigabytes of RAM, 32 gigabytes of RAM, that's going to be able to handle a lot more information rather than maybe 8 gigabytes of RAM or 4 gigabytes of RAM that you see with budget computers. Now, with persistent memory, it's memory that doesn't delete when the computer shuts down, right? An example of, non-volatile memory, of course, is the hard drive or solid state drive. This is otherwise denoted as non-volatile memory. And well, you want that at memory, you want that data to be kept, right? You don't want to shut down the computer and lose that data, right? So in that regard, you would store it in a hard drive or solid state drive. Now let's talk about software. Software are programs utilized by the computer to execute certain functions, made with a variety of computer languages. So, and well, there are three types of languages that are generally used. We're going to be focusing on high level languages with this course or with this workshop because, well, Java is a high level language. But it's important to note that machine language and assembly language really guide us to how we navigate through, well, software. So machine language is like, your vanilla code. Not, I mean, what do you call vanilla code? It's like the most organic, right? It's consists of binary or hexadecimal instructions, again, binary code. So this is ultimately what the computer interprets, right? It doesn't really interpret human words. So those human words that we know are translated into, well, machine language so that the computer can interpret it. But like the average programmer is not going to be coding in zeros and ones, right? I mean, it would be cool, but at the same time it would be so tedious and it would really suck the fun out of computer science. And on top of that, it's not even practical at all, right? So we would save that to the people that develop programming languages, so mad respect to them. We also have assembly languages. This is a low level programming language, and it does have the few additions of human words. However, this is generally more for hardware manipulation. It isn't more for, I mean, you can use it for software development, but like, again, it's more for, hardware manipulation. So it's low level. It's not as high level, which is what we're, going to be using this course, Java, for example. This is closer to a human language and it's friendly for programmers because, well, you can understand it. You can kind of guess through pseudocode first. You can develop a program through pseudocode, right? And then you could test it out pretty easily with a high level language, assuming that the syntax is there. Again, I said Java is an example. Okay. So I think that's the end of my presentation. Okay, yeah, that's the end of my presentation. Let's move on to the actual programming for today. I'm hoping to cover all this material. It might be fast, but yeah, I mean, my workshop is always recorded, so you could always go back to it. Otherwise, otherwise, um, you can always ask me questions. It's not a problem. Okay. Might as well start from the very beginning. I might skip around because mainly I designed this to be more of like a explanation based, but like computer science isn't really like, PowerPoint based, right? PowerPoints are good for introducing the material, but it isn't really good for teaching it. So again, to reinforce the skills, what I would do is I always switch between the Eclipse browser or the Eclipse IDE, right, that I use. And if you're using JGraphs, then there should be you first save it as a file, as a Java file with the class name that you see here as the file name.java, and then, run it. There should be a, compile and then execute, or compile and then run. Compile allows you to find syntax errors, and then the run allows you to actually run the program. In this case, I do it simultaneously. Anyway, expressions, operators, and control structures. So what I'm going to be covering, hopefully I want to cover all this material by like 10 o'clock. If not, we can always go and push some of the stuff if it gets too tedious or gets too much in a short amount of time. But again, that's the blessing of recording these types of videos because, well, you can always go back to them. Anyway, so relational operators, logical operators, short circuit logical operators, assignment operators, increment and decrement operators, operator precedence, if else statement, while loops, and for loops. So the first three things, I mean, the first couple things here on this list, kind of expand on the Java basics. However, with these control structures, the last three things, you're going to be using them. If you go into computer science, I don't think you ever will lose them, right? This is a concept that is very applicable in literally any field, any language that you will learn, any programming language that you learn. So let's discuss relational operators. So this is my sort of cheat sheet for relational operators. A relational operators allows you to, well, compare values, right? Generally, you're going to be using numerical values, but you can also use relational operators with like strings. I'm not going to talk about how you can use them with strings or like, and when I mean strings, I mean, pieces of text or pieces of characters, right? I'm going to do that in a different workshop because that might get a little bit confusing. But for now, I'm gonna just use numeric answers, numerical values as an example. And here are the examples of relational operators. And what they do is that they compare two numerical values together, and it could either spit out a true or false value. It either returns a true or false value. And you could use that in a control structure. Later on, I'll show you how you can use it in a control structure. But for now, I'm just going to store it in a Boolean value, because what is a Boolean? A Boolean value is either true or false. So we can technically store, if this relational operator returns a true or false value, that means that we can store it within a Boolean value. So you're probably wondering, why do we have double equal sign? Why can't we use the double equal sign to show that, we have, if we want to compare two numerical values together to see whether or not they're equal? Well, we already used the equal sign example, as I show here, to assign values to variables. And so we don't want the computer confusing over assignment operator. So this will be considered an assignment operator, the equal assignment operator to relational operator. Anyway, that's just why we have a double equal sign in that regard. Anyway, um, the first relational operator is equals, double equals, and this really sees whether or not if the values are equal to each other. So if I have a value, numerical value that is equal to 50, it's going to see whether or not 50 is equal to 50. And if 50 is equal to 50, well, then this Boolean Z is going to be equal to true. But if A is any value that is not 50, then it's pretty much going to be false. So if A is any value that is not 50, then Boolean Z is going to store a false value. Now with not equals, this is pretty much the opposite of what the first Boolean value was. So we have Boolean Y is equal to B uh, not equal to 60. So if it's actually equal to 60, right, that is not a true statement. 60 not equal to 60. That is a false statement. So this would be false. But if it's any number that is not 60, if B is any number that is not 60, then it would return true, because, well, 61 is not equal to 60. That's true. 62 is not equal to 60. That's true. Again, you have to think of it like that. Um, it might be a little bit funny to think of it like that, but that's how we think about these type of relational operators. You also, of course, have your greater than, less than, greater than or equal to, or less than or equal to operators. And these are rather simple. So if C, for example, is 71, then this would return true, because 71 is in fact greater than 70. And, but, if it was like, let's say 69, for example, right? Nice. 69, for example, then it would be false, because 69 is not greater than 70. And it holds true for every single value here. And it's important to note that there is a distinction between greater than and greater than or equal to, because if I put C is equal to 70, if I put C is equal to 70, then this will return false. But if I put E is equal to 90, then this would be true, because we have that equal sign. So again, that's not there because, the computer can interpret that. It knows the difference between the two. So let me show you how this works in the compiler. And it's important to understand how relational operators work, because generally you're going to use this in two, you're going to use this generally with for loops and maybe even if statements. Technically, you would use this in a combination with if statements, but again, I don't want to make it sound too difficult. So we have a Boolean, let's say, let's make a Boolean value. And this is where we're going to store our relational operator. So if we have like 50 is not equal to 50, right? Let's system.out.println the Boolean value val. Okay. Now, before we answer this, before we compile and run, is this going to return a true or false value? Well, 50 and 50 are the same value, but this is a not equals, right? Is 50 not equal to 50? No, it's not. 50 is in fact equal to 50. So this is a false statement. And if it's a false statement, it's going to return, well, false. And it returns false. So to make this true, I would use a double equal sign if I want to just change the relational operator. Or if I don't want to change the relational operator, then I could just change one of the numbers. Is 51 not equal to 50? Yeah. That's a true statement. So it's going to print out true. And again, a true and false are Java keywords. It can actually interpret true and false. It's not a string. True and false is not a string unless you put the double quotation marks. Then it becomes a string. But in the case of no string, or sorry, no quotation marks, then it actually can determine, it actually knows what the meaning of true and false is. And you can use that in a variety of applications to allow the computer to pursue a choice. So again, it might seem like, why is this necessary right now? But trust me, it makes a lot of sense. Hopefully, if we discuss it by the end of the video with the control structures. And well, you can also use other relational operators such as greater than, right? So this would be a true statement because 51 is in fact greater than 50, which is true. But if you do, let's say, actually, let's say if you do 50, for example, is 50 greater than 50? No, that's false. So in order to fix that, you would either put the double equal sign, or you could just simply add greater than or equal to, and this would be true as well. So I'll let you experiment with that. Okay. Now let's talk about logical operators. Now, logical operators is something that we should be aware of because they have very powerful applications, generally with control structures when it comes to, well, assigning, allowing the computer to take a course of action. So what I mean by that is, it allows the computer to determine like a certain context and then make a logical choice between them. And we're going to be learning and, or, and the not operator. Okay. So logical operators are just operators that interpret compound Boolean expressions and return true or false value. Basically, there's multiple Boolean values together, right? Boolean expressions. So an example of a Boolean expression is what we did previously, right? That would be considered a Boolean expression. I deleted it. Actually, let me see if we have it here. Yeah. So this is technically a Boolean expression because it returns a true or false value. And since it returns a true or false value, we can use that in conjunction with other Boolean expressions and create a compound Boolean expression. But in this case, we are discussing logical operators, and the return value differs given what logical operators used in the actual Boolean expression themselves. So the AND operator returns true if all the expressions in the compound Boolean expression are true. So an example of this is our one Boolean expression is 4 less than 5, and then we have another Boolean expression that is 3 less than or equal to 4. And then we have our logical operator in between it. And you can use multiple logical operators. So I can put like and here, and then put another Boolean expression, and you can continue like that, right? But for now, just to keep everything simple, I have this simple one Boolean expression and another Boolean expression. So it's 4 less than 5. Yeah, that is a true statement. Is 3 less than or equal to 4? Yes, that's a true statement. Since both of these are true statements, this returns false. Sorry, it returns true because, well, both expressions are true. So both expressions have to be true in order to return true. Now let's look at the second one. Is 6 less than 9? Okay, that's a true statement. Let's move on to the next one. Is 3 greater than or equal to 4? No, unfortunately, that's not. So we have a true on one side and we have a false on another side. According to the definition of the AND operator, both sides have to be true. And unfortunately, since we have a false on one side, this entire thing becomes false. So the compound Boolean expression that we have here is false. Oh, okay. Might as well just show it to you also. So we have, for example, this Boolean expression, and let's combine that with, let's say, let's do 31 is equal to 31. So let's see if this will be true or false. So is 50 greater than or equal to 50? Well, yeah, that's a true statement. Is 31 equal to 31? Yeah, that's a true statement. So hopefully this should print out true. And it does print out true. But what happens if one of the Boolean expressions is false? So is 30 equal to 31? No, it's not. So we have a true Boolean expression here, and we also have a false Boolean expression here. And that will return false. So if you really want to make things simple, I mean, this is literally being interpreted as true and false. And as you can see, well, since the Java compiler can interpret true and false, it returns false because, well, one of the sides is false. This is logically equivalent to this that I put it here. And of course, it has the same result, false, when you express or deduce the Boolean expression, the overall Boolean expression. You can represent it in a chart pretty easily. So if one side is true and the other side is true, then, well, you're going to get true. But if one side is false and, you know, one side is true or vice versa, right? If the term, depending on the side, it will always return false. And of course, if both of them are false, then it's going to return false because there's no true value. We also have the OR operator, and it's represented with these, long pipes. It returns true if only one of the, well, not if, it returns true if at least one of the Boolean expressions within the compound Boolean expression is true. And, well, if all the Boolean expressions are false, then it will return false. So an example of this is if 6 is less than 9 and 3 is greater than or equal to 4. Is 6 less than 9? Yes, that's a true statement. Is 3 greater than or equal to 4? No, that's a false statement. But since one of them is true, then it returns true. Okay, so now let's do, okay, yeah. Is 6 greater than 9? No, that's a false statement. Is 3 greater than or equal to 4? No, that's a false statement as well. So since both sides are false, then it returns true. And you could represent it like this. As you can see, there are more scenarios where it could be true. So if one side is true, if at least one side is true, then it's going to return true. So, and if both sides are true, it will also return true. But if both sides are false, 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 it will return false. So let's just quickly represent it here, right? So as you could see, right, this previously returned false. Why? Because, well, this statement was false, but this statement was true, but you would need both statements to be true in an and statement. However, if I make this a logical or statement, now you no longer need both of them to be true. You only need one of them to be true. So in this case, this one pretty much seals the deal to return true. We also have the not operator, and it's a lot more simpler than you think it is. It reverses the Boolean expression, really. So just like how it, like, not really just, tested to see whether or not something was not equal to something. Well, by putting this exclamation point next to any Boolean value or even a Boolean expression, it just flips it to the opposite value. So if I do this exclamation point X, and we can assume that X is true and Y is false, then it will return false. But if I do the same thing with Y, it's going to return true. It's just doing a flip-flop. So for example, if I do, let's say if I do this, let's see if this changes it. Okay, and it changes it from true to false. Why? Because now we no longer have a true and we don't have a true value on either side, because this not operator changes the one true side that we had to false. So this is technically true, right? So 50 is greater than or equal to 50. That is a true statement, right? But this not operator changes it from true to false. So this is true, but this is false. And since this is false and this is false, both sides are false. There's no true side, and it returns false. And, well, you have this sort of cheat sheet here, and it's rather simple, right? For exclamation point on a true statement, it's going to be false. For an exclamation point on a false statement, it's going to be true. I mean, you could even technically simply write this as, let's say, let's do true. See if this works. And as you can see, it prints out false. But if you do, let's say, exclamation point false, it's going to print out true. Again, it just reverses the Boolean value. It's really weird to see it like that, but it gets to the point. Now, short circuit logical evaluation is pretty easy to understand, simply because, well, it just logically makes sense. So let's say if you have like a double AND operator, technically both sides have to be true in order to be for the overall thing to be true, right? But if the first thing it sees is false, then it could assume that the entire thing is false, right? Because it would need a true value, but it doesn't have the true value. Everything needs to be true, right? So if it already found a false value, does it really need to check everything else to, see whether or not it could be true? No, right? Because that would logically not make sense. You already found that one of them was false, so the entire thing has to be false. And then with the logical OR operator, it's a little bit more different, but the same concept applies, right? You need at least one true operator. You need at least one true Boolean value or Boolean expression. And in that case, right, once it finds that true value, even if it's like, let's say if the first Boolean value is true, then, well, it doesn't need to check the other values because it only needs one true value to make everything true. So here's an example with AND operators, right? Is 6 greater than 9? No, it's not. That's a false value. So the computer already knows that without even checking this, that this entire thing is true. This entire thing is false because, well, the first statement is false. This can be true or false. It doesn't even matter. Since this is false, this entire thing is false. Now you have the OR operator here, right? Is 6 less than 9? That's a true statement. It doesn't matter if this statement is true or false. The next statement over here that I'm circling right now, it doesn't matter if that's true or false because we already determined, or the computer rather already determined, that this side is true. And since this is an OR operator, it only needs one true for the entire thing to be true. So, well, it returns true in that regard without even seeing the 7 is less than 9. In both compound Boolean expressions, the second Boolean is not even evaluated. Now, let's discuss assignment operators. You already know one assignment operator, and that's, well, the basic assignment operator with the equal sign. And like I said, it's different from the relational operator with the double equal sign. So, you declare an integer x is equal to 5. That's how you use the assignment operator to assign a new value to a variable. Now, but there's actually a bunch of ways that you can actually assign values to variables, right? So we have the plus equals, and that's simply equivalent to x is equal to x plus 5. So if I have, let's say, if I declare an integer saying integer x is equal to 5, let's do integer x is equal to 6, right? Just to, separate it from there. And I put this statement here, then it simply accesses the previous 6 plus 5, and then x becomes 11. And it does this with every single one. So if this is like -5, let's say if we declare integer x is equal to 6 and we do every single one of these operations, not in order, of course, or not simultaneously, just to show you just how each of them works. This would be 6 minus 5. That would be 1. This would be 30. This would be, well, that would be 1 because, again, we didn't cast it. And then this will be, well, 1 as well because 6 the modulus 5 would have a remainder of 1 because 5 fits into 6 one time. Yeah, let's test this out. Might as well. Okay, so we already used the assignment operator, basic assignment operator, and this prints out, well, the value that we have. Oh, we're not printing out val. Okay, so we print out val. Okay, let's do that. Now let's add 5 to the value of val. So what would this do? It would simply increase the value of val by 5, right? So this is equivalent to val is equal to val plus 5. The new value of val is equal to the old value of val plus 5. You could also do minus. If we do 5, for example, actually, before we do that, let's see if that, yeah, this actually works. So hopefully by doing this, it should go back to 5 because it removes 5 from the value. And this has like a canceling effect. Since we add 5, we remove 5. I mean, if we do, let's say 7, for example, wouldn't that be negative? It would be 3. That Zoom thing gets in the way. Yeah, it would be 3. And just to show you that division is still a thing there, let's do, I believe it was this 5. Was it that? I completely forgot. Okay, there you go. I generally don't use this. I don't generally like it, but these are assignment operators that you can use. And yeah, the result is, well, 1. And the result will be the same even if I do, let's say, 6, for example, because if you recall from our casting video or from our workshop 1 video, right, with division, if you have 2 integers, it's going to return an integer. So, well, 1 is an integer, right? It's not going to return the decimal unless you make, for example, one of them a decimal. So if I do double, for example, this would actually return the decimal answer. For now, we're dealing with integers. Okay, we could do increment and decrement operators. And again, I'm really just focusing on the elements that we're probably going to end up using in the control structure. So the for loops, while loops, and if and else statements, right? So I'm trying to build up all the skills because, well, these are definitely required skills to know when you're building those applications or building those control structures. Hopefully I'm not talking that very low. I know I talk a little bit low because it's nighttime right now. Anyway, learn the increment operator, learn the decrement operator. You already know that. So you have the double plus sign. What this does is that it's logically equivalent. I don't know why the n comes after that. I should probably fix that. But that's simply just increasing the value by 1. Now, I want you to, there's a distinction between this, and there's a specific reason why that a lot of people don't, often a lot of people overlooked, right? They both increase the value by 1. So technically speaking, they both do the same thing, right? But the thing is that it's how it's interpreted and like in what order is it interpreted in. I'll show you how it works, the distinction between them. Decrement is the same thing, right? There is a distinction between whether or not you put the double minus sign before or after the variable or the number that you have. And then you have that being equal to x is equal to x minus 1. Okay, so for now, let me erase this and okay. So let me show you what happens when I increase the value if I put the double plus sign before val in the print statement. And as you can see, it prints out 7. So it's increasing it by 1. But what happens if I put it after? It's now 6. However, it does increase the value. So if I actually print out val again, you're going to see that respective change now. So the placement of the increment operator is very important depending on how it gets interpreted. So if you have it in the print statement, for example, if it sees the plus sign, if it sees the plus sign first, it's going to increment val before it prints it out. But if the increment operator comes after the variable name, then it's not going to increment it until it prints out val. And then once it prints out val, then it's going to increment it. We see the same scenario with decrement. So like if I put this value before, it's going to print out 5 both times. But if I put it after val in the first print statement, it's going to print out the number 6, and then it's going to print out 5 because we decremented it after we printed out val the first time. Okay, so what is the, oh, well, we already did that. Let me skip this, let me skip that. This is a thing called operator precedence. Honestly, even I haven't memorized this. I just remember to, like, remember the parentheses is the first one. So you always interpret the parentheses first and generally think about PEMDAS. So if you have taken a math class, right, you definitely have probably have heard of PEMDAS, and PEMDAS is simply just the order of operations. Computers have their own sort of PEMDAS, and I have the operator precedence here. So the higher it's there, the first it gets computed or the first it gets evaluated. And if you look at the bolded ones, more specifically 1 and 8, the bolded precedence is evaluated from right to left, but the other ones are evaluated from left to right. So just keep that in mind. I'm not going to discuss it too much because, to be honest, like even I haven't been aware of this. I'm sorry, not been aware of this. I know that this exists, but I don't like actively memorize it or look at it. I have like a reference sheet. Let me skip all this stuff. This is just a bunch of practice problems that I make. Okay, let's do some control structures in the last 20 minutes. If and else statements. So what is an if and else statement? So this is the syntax for an if and else statement. With the if statement, there's this sort of, you first declare if, and then you have a Boolean expression here. And if you recall, what does a Boolean expression return? It returns a true or false value, or it could be a true or false value altogether, right? So if you have like a value, for example, it would be stuck here. But what I'm trying to say here is that generally this would evaluate the true or false within here. Now, if it's true, then it will execute whatever is in between these curly brackets. Now, if you don't have curly brackets, but you do have an if statement, the next line is the only thing that gets executed, right? The next line is going to be considered your if statement, but I like putting curly brackets, even if it's only one line, because it keeps the programmer organized. But if you like, trying to make it like, very basic and you don't want to put curly brackets, the ifs for the if statement, the next line is going to be your the next line is going to be your only executable part of the if statement. But in this case, anything that's in the curly brackets, you could put multi-line values, multi-line Java statements, and it will only execute as if the Boolean expression is true. Now, if it's false, it's simply going to ignore it with this regard. In this regard, it's going to ignore it. However, actually, let me give you an example. So if 5 is greater than 3 and 9 is less than 21. So what is this? This is a Boolean expression. And what does this Boolean expression return? Either a true or false value. So let's determine that. Is 5 greater than 3? Yes, it is. So that's a true value. Is 9 less than 21? Yes, that is a true value. So since both of them are true, and we have an AND operator that requires both sides to be true, then it will print out that the Boolean expression is true. Now, like I said previously, right, you can also have an if and else statement. So what is an if and else statement? Basically, if this Boolean expression evaluates the false, then it has another route to go to, right? It doesn't have to like, skip the if statement altogether. You're basically giving the computer a different path, right? So if it determines if a context is true, if the Boolean expression rather returns true, then it will execute whatever is within these curly brackets, right? These Java statements. Now, if this returns false, it will go into the else statements and then it will execute these. So if you have an if and else statement written like this, right? You can also have a bunch of other if statements and else if statements, which I'll discuss a little bit later. But in this sort of syntax, in this sort of vanilla form of an if else statement, right? Generally, one of these is going to be executed no matter what, because, well, if you do true, then there's only two paths that it can go to, right? If you do true, then it will execute this. If you execute, if this is false, it's going to execute this. So one of these things is going to get executed, right? And then after that, it will proceed with the program after the else statement. So if you have a question like this, how can we determine the answer? Integer x is equal to 20. If x is greater than 21, is x greater than 21? Is 20 greater than 21? No, that's a false statement. So since it's a false statement, it goes to the else statement. And then the else statement has its own println statement that it executes. And it says x is not greater than 21. So x is not greater than 21. Now you also have else if statements, and this is just a fancy way of saying that we could put multiple Boolean expressions together before the else statement. So you have a Boolean expression, you also have another Boolean expression, right? And then you have the else statement as usual. And well, at least one of these three things is going to get executed no matter what, because, well, we have this else statement here. Right now, if we didn't have the else statement, you could technically make a case saying that these two statements will probably never could potentially never be executed, and nothing within this sort of control structure, like I would say, or this control structure would actually get executed. But since we have the addition of an else statement that accounts for both true and false values, true meaning that, if it's true, then it will execute with this or here, and then an else statement, which accounts for all the false values. So let me provide you an example, and this is rather conceptual, but I think you guys can understand it. Integer x is equal to 18. Is 18 greater than 19? No, it's not. That's a false value. So we go to the next else if statement. Okay, we have, is 18 greater than 19? Okay, yeah, it is. Okay, yes. And then it will print out x is greater, or sorry, this is a false statement because 18 is not greater than 19. I was looking at the other one. Else if, is 18 less than 25? Now that is a true statement. So X is in fact less than 25. And you could simply rewrite the you could do else if statements, but there's also a thing called nested if statements, which is an if statement within if statement. And the syntax is actually logically equivalent to the and operator if you have a Boolean expression. So if you have a Boolean expression here and a Boolean expression here, and it has to, in order for this Java statement to execute, it has to go through this if statement and this if statement. It's going to have to, these Java statements have to go through these both Boolean expressions. So technically speaking, these have to be true in order for this Java statement to execute. So you can rewrite this whole thing as, well, Boolean expression 1, Boolean expression 2, because those expressions have to be true in order for this Java statement to execute. And I don't think we need to worry too much about this nested if statement, but you could do this practice problem a little bit later. Okay, so let's start off basic, right? So if true, so that's going to be our true system.out.println Boolean. Actually, let me do expression true. Well, we have that expression is true, and we can also put an else statement. Let me copy this. Let me paste this. Let's do false. I want to make sure that nothing is wrong here. Oh yeah, okay, so it's giving me an error because, well, technically speaking, the else statement will never execute. And as you can see, since this is Boolean expression of values to true, since I literally plugged in true, then, well, system.out.println expression is true. But let's see what happens when I put false. Right? So if I put false, for example, this Boolean expression is now false, so it doesn't execute this. It now executes the else statement. And we could, apply that else if statement logic here too. So if we put, let's say, else if, right? Let's do expression 2 is true. Right? It's still going to be expression is false because, well, both of these are false. But let's say if we make this true. Now it says expression 2 is, well, true. Now, generally, you're not going to plug in false and true directly into a Boolean expression. You're going to have different values. So let's say if let's say 5 is greater than 3. Right? Is 5 greater than 3? Yeah, it is. So it's going to say expression is true. And it reads it from top to bottom. So it doesn't look at the else if statement first, then the if statement, then the else statement. So if this is true, this is going to be true. And then it's not going to look at the else if statement and the else statement. If the else if is true, then, well, it's going to not look at the else statement. And if the else statement is ultimately our last resort, then then we know that logically it has gone through all the if statements and else statements that have come before it. Else if statements, rather. Now, generally, you're not going to, like, plug in numbers like this, right? Now, that was just an example I was trying to show you. What you would most likely do is actually get user input. Hopefully that is the Java scanner. And let's do scanner, new scanner, equal to new scanner, system.in, like we did in the last workshop. This is to create what? This is to give us the ability to get user input. So integer input is, let's do my scanner dot next int. So we want to get an integer from the user. And let's do if input is greater than 3. Oh, okay. Let me erase this. Okay, let me move that as well. Let's do input greater than 3. Input less than 3. Okay, so let's test out a program. We have an error here. Where it is the error? Oh, it's not my scanner, it's new scanner. Okay, so let's plug in a number, let's say 2. Input is less than 3. Okay. So yeah, that is true because the value that we input into our, the value that we inputted into our scanner, right? When we put into the if statement is 2 greater than 3. No, it was not. This is a false statement. So it goes to the else statement. And in fact, 2 is less than 3. Let's see what happens when we put something different. So if I put 4, is 4 greater than 3? Yeah, that's a true statement. So it's going to say input is greater than 3. Input is greater than 3. Now let's try to account for, mistakes, right? So what happens if I put 3? It says the input is less than 3, which is not really true. So if you look at this if statement here, it's not accounting for whether or not 3 is actually equal to 3, whether someone inputs the value 3. And we can go about this a variety of ways. We can make another else if statement. For example, let's do else if, and let's do is if input is equal to 3. And if this is true, right? Let's do input is 3. And then that is our way of sort of debugging it, right? Input is 3. And you could also change the output as well, right? You don't have to change the algorithm itself. You could also change the output. So for example, I could put this as equal, right? And then I could put input is greater than or equal to 3. Or I could also in the else statement put input is less than or equal to 3. And these are just different ways that you could tackle the issue. Again, you have to keep it in mind or account for these things. Okay. Okay. Next thing, we have for loops. Do I need to do for? Do I want to do for loops? Honestly, let's do while loops first. While loops are pretty easy for. So first, I'm going to do while loops. Then I'm going to do for loops because while loops are more practical to teach to someone beginner, and then for loops will build upon the skills that you have from while loops. So it's basically an iteration. What is an iteration? An iteration is a repetition of a process. And well, we're going to be learning about the while loop and for loop. So a while loop is a type of iteration that executes as long as the Boolean expression evaluates the true. So think of it like an if statement, but the if statement keeps executing, executing, and executing, and executing until the Boolean expression that controls it is false, right? So if it's true, it's going to keep on going. So this is the syntax for a while loop. So you have while because, well, it's a while loop. I know, right? While. And then you have the Boolean expression. And then if this is true, it's going to execute the Java statements and then go back to the Boolean expression. If the Boolean expression is still true, then it's going to execute the Java statements and it's going to keep on going until this Boolean expression reaches false. So this up, okay, yeah. So there lies the important mission to actually control the Boolean expression in a way that allows us to actually stop the while loop. Why? Because what happens when you have a while loop that infinitely goes, right? What happens is that it's going to be using RAM, it's going to be using memory on your computer, which hinders not only performance, but your ability to make efficient programs that actually have functionality. If you have a while loop that is, infinitely running in a non-practical setting, it wouldn't really be a good program to actually build. That's what I'm trying to say. So you have to be more efficient and you have to be using it in a correct scenario. So here's an example. We have integer I equals 0, and integer I equals 0 is going to serve as a loop control variable. So we have is as long as I is equal less than 3, then it's going to be printing out I. And well, I increment after every iteration. And the reason why we increment the iteration is so that the Boolean expression finally values the false at one point it is iterated or after a couple iterations. So in this case, it's going to print out 0, 1, 2, and then, well, it's going to end because when it reaches 3, 3 is not less than 3. 3 is in fact equal to 3. So once it's false, then it quits the while loop. All right, so in this case, we have integer I equals 0, and it says while I is greater than 5. Well, is 0 in fact greater than 5? No, it's not, so nothing will get printed. Let's do integer I is equal to 1, right? And while I is greater than 0, system that out that print I. So it's going to print out 1, 2, 3, 4, 5, and then it's going to keep on infinitely looping, infinitely iterating until it just crashes. Okay. So let's create a while loop that prints out all the numbers from 0 to a number that the user inputs. So I already have the scanner class set up and then it gets a user input. So let's do integer loop control is equal to 0. Now, as long as the while loop, right, as long as the loop control variable is less than equal to input, I want it to print out. I'm not going to use ln because that's going to create a new line. I wanted to print out the loop control variable and then space it. Now I can't leave that there. We have to increment the loop control variable. Why? Because we don't want this to be infinitely looping. Okay, so let's enter number, let's say 4. It's going to print out 0, 1, 2, 3, 4. So this actually, the while loop actually iterates 5 times, 1, 2, 3, 4, 5. And we use a loop control variable not only to print the numbers, but also control the number of iterations the while loop actually performs. And this is not only efficient, but it does the function that we want the computer to do. So very, very basic program, right? Gets some user input from the user, an integer user input, as denoted by this method, and then iterates the while loop the amount of times that we want it to be iterating. Okay, let me go back. Now, this is where the fun really begins with control structure. It's really, I mean, for loops are pretty much the most widely understood loops that programmers see, mainly because they have very powerful applications. And I use this all the time with arrays and array lists. Now, you don't have to understand what those are, but it's really just oh, wow, I'm pretty sure, I don't know what browser I'm using, but I'm guessing Google's using a lot of RAM memory. It says here this web page is using significant memory. Anyway, let's discuss for loops. So again, iteration is just a repetition of a process, and we can achieve that through for loops and while loops. But with this case, we're going to use the for loop. Now, this is the syntax for loop, and it's not going to make sense now, but it's going to make sense later when I actually use the for loop. But this is the general structure of a for loop. So you have for to actually represent the for loop. I know, for loop using the word for. The first part of it, of the parentheses, is not, this entire thing is not a Boolean expression, by the way. There's actually 3 parts to this for loop, the parentheses. You have the initialized variable part, you have the condition to terminate, which is like this is the actual Boolean expression, and then this is the update one. This updates the loop control variable. So rather than creating a loop control variable outside the while loop and then updating the loop control variable within the while loop, this for loop accomplishes that with one single line. Actually, let me make sure. So you initialize a loop control variable, right? And then as long as that loop control variable evaluates to true within this Boolean expression, it's using this Boolean expression. As long as the Boolean expression evaluates to true, this for loop is going to continue executing, right? And then after every single iteration, what it's going to do is going to go update the value. So it updates the value, and then it goes back to condition to terminate. And as long as this is true, it's going to continue executing the Java statements, updating, and then coming back to condition to terminate. And eventually it should return false, assuming that we're very good with our algorithmic thinking. So let's look at this as an example. So we have for integer I is equal to 0. So we're declaring an integer I equals 0. And it's going to only exist within this for loop. So if I access an I outside the for loop on the top or the bottom, it's not going to work. we have to create another I. But in this case, I is declared within the scope of the for loop scope, meaning, the environment of the for loop where it exists, right? Where the variable exists. And as long as I is less than 5, I wanted to print out the Java statements within the curly brackets. And then once it's done actually executing the Java statements within the curly brackets, it's going to update the value of I and then go to the condition to terminate. So it's going to do integer I is equal to 0, check if I is less than 5. So 0 is in fact less than 5, and then it's going to print out 0. Then it's going to go to the update variable. It's like, okay, I is no longer 0, I is 1. And then since I is still less than 5, is 1 less than 5? Yes, it is. So we print out I. And then we update the value again after all the Java statements have been executed. 2 is less than 5. That is true. Then, we update it. It's 3. Is 3 less than 5? Yes, it is. Update is 4 less than 5. Yep, update. Now is 5 less than 5? No, it is not. So it stops at 4 in that regard. Let's try this. Again, we're using a different type of assignment operator. If you recall, what does assignment operator do? It simply increases the old value of I by 10, or by the value that you have here. So in this case, it's going to be 10 because that's the number that I put here. So integer I is equal to 0. As long as I is less than or equal to 50, I increments by 10 values or 10 numbers. So it prints out I is 0. So it prints out I. Updates, so I is no longer 0, I is 10. Is I 10 less than 50? Yes, it is. So it prints out 10. Updates 10 to 20. So is 20 less than 50? Yes, it is. Then it does it again, 30, 40. And then this time it also includes 50 because 50 is in fact less than or equal to 50. However, once it's done with 50, it's going to increase the value by 10. And 50 is I is no longer 50, I is now 60. And is 60 less than or equal to 50? No, it's not. So it ends there. We also have this thing called nested for loops. And again, this gets a little bit messy, but it has a very powerful application. Generally, I use this with 2D arrays, 2D, two-dimensional arrays, and two-dimensional arrays is a type of data structure that you don't have to be aware of right now, but just know that that is a potential application of nested for loops. So if you see here, we have a for loop here, and then we have a for loop here, and these are really easy when you think about it, but you always have to keep track of the number. So you can't be conflating this for loop with this for loop unless it's necessary or unless they have some type of for loop relationship. As you can see, the value of j actually depends on the value of I. So you have to keep track of I with respect to j as well. But technically speaking, I is not dependent on j, but j is dependent on I. So if you do integer I equals 1, I is less than 5, I increments, right? You already know that this outer for loop is going to iterate 5 times. So if it iterates 5 times, that means that how many times this will update will depend varying on the value of I. So it starts with 1. So integer j is going to be 1. And then it increments by 4. So increments by 3. So it's going to become 4. And then it's going to increment by 3. 7 is 7 less than 12. Yes, it is. So it's going to be 7. Increments it 10. Increments it by 3. It's going to be 10. Is 10 less than 12? Yes, it is. So it's going to be 10. And now it's going to update again. Is 13 less than 12? Yes. No, it's not. So it's going to go to this inner for loop is done. So it's going to go back to the outer for loop. It will also, I put this println statement here for a specific reason, because if you have a print statement and you want to print it out very nicely in a two-dimensional way, what you would do is you would actually make an empty println statement. And what this will do is that it will stop the compiler from, or stop the computer from running things on the same line. So it's going to start a new line because of this println statement. So I is now 2. So j is going to start out at 2. It's going to be 5. It's going to be 8. And it's also going to be 11. And we can continue this pattern mathematically. We can trace that as well. Okay. So let's just code one for loop just for the heck of it. And it's rather simple. Again, we could do the same thing that we did with the while loop. So for integer I is equal to 0, right? As long as I is less than or equal to the input that we get from the user, I is going to increment And well, system dot out dot print. It's gonna be I. Let's do plus, and boom. Okay, so let's for example 7, and it's gonna print out all the numbers from 0 to 7. Now, if we want to make a nested one, we can make like sort of like a mini triangle here. Let's do 4 integer j. Now I still exists, so technically speaking, we could do I here, and as long as j is less than input, then let's increment j. And do system.out.println, and rather than printing I, let's print out j. And then after every new line that, that we have with this inner for loop, we're gonna create a new line so that the next row can start. Okay, so let's do 5. Oh, okay, I made a mistake. Why? Because I put the ln here. Okay, let's put 5. And as you can see, we have that sort of mini triangle going there. Actually, let me put the equal sign there so it includes 5, because 5 is a nice number. I like 5. And there you go. See, we have 0, 1, 2, 3, 4, 5, and we have that triangle built because we have that inner for loop that executes and it's dependent on the value of I, but then you also have the outer for loop that's going to execute. Well, since we imported 5, it's going to iterate 6 times since it starts at 0. And you could experiment with it as much as you want. And this has a variety of applications. I know that I kind of rushed all of this. If you want, if you want, I'm willing to look at potential applications in the next workshop. Actually, let me close this out right quickly. So let's stop the share. I can't see my face for some reason. Let me do this real quick. Okay. Oh. Okay. Okay, let me close this as well. And now I finally see my face. So I know I did this workshop rather quickly, but if you want me to, I'm willing to go over the applications in the next workshop. I'll think about it. But with these past 3 workshops that I've gone through, I've pretty much covered all the basics of the Java programming language that you need. Now, what you're going to do is use this sort of basic Java knowledge, such as control structures, such as assignment operators, logical operators, to create more advanced programs. So I'm going to still decide about this over the next week, but this I'm willing to spend one workshop just sort of solidifying the skills that we developed in this workshop. Again, it's recorded, so you can always go back to it. And you can watch it there in that regard. But in the case that I have right now, I'm going to either just solidify the skills that we made this video uh, through more practice problems, more programming knowledge, or more programming, more programming practice on the compiler and the Eclipse browser, and that could be a different bunch of different algorithms. I know a bunch of different algorithms or different problems that we can test out. Or we can get started with object-oriented programming, which is where the real fun begins when it comes to computer science, or introductory computer science to be more specific, because that's when you start envisioning objects from our real world and translating it into a computer. And like, just to give you like an example, right? I mean, just think of like a board game, right? If you think of like checkers, right? You could have the board as an object. You can have every single piece that the people use. The checkers can be each be another object, and then they can have their own specific actions. And imagine trying to program that on a computer, right? The philosophy or the logic behind object-oriented programming, or allows us to perform things that we would normally do in person on the computer. So getting that sort of envisioning done in the compiler, or doing that through this workshop, next workshop, hopefully would open a lot of doors into not only computer science with a Java programming language, but also computer science in other languages, because object-oriented programming is not only a thing in the Java programming language, it's a thing in a bunch of other languages. But I know for Java specifically, it's used in Android development. So if you know object-oriented programming and you know the Java programming language, you can kind of get started with you can get started with making Android applications. Um, I know Flutter is also a very popular framework, I believe, right? So that's really being Java would be a good language to study before you learn the Dart programming language that Flutter uses. And that will help you build applications with Android as well as iOS, since they're cross-platform. I know that I'm going off track here, but again, this has computer science kind of edges it off, but it has a variety of powerful applications. I'm going to stop recording right now. And if you have any questions, feel free to ask.